Hi class, this is course 3, lesson 73, formulas for sequences. So we've talked about sequences before, and this is just an extension on sequences. Here's an example. We're going to find the 8th and 9th terms of the sequence generated by the formula a sub n equals 3n. And remember when we're talking about sequences that we have a position number or the term number, and we have the value associated with it. And this little n here is going to be the term number. Okay, so if we want the 8th term, we say a sub 8 equals 3 times 8. We're going to let n be the term number that we want to find. So we want to find the 8th term number, so n equals 8, and then we evaluate. So a sub 8 equals 24. And we'll do the same thing with the 9th term. A sub 9 equals 3 times 9. So the 9th term is 27. Okay, so get used to writing in the sequence formula with the subscript notation. If you see this, this is your answer. It should have the term number in it. Okay, you'll also be asked to find terms. So in these cases here, we're going to find the next 2 terms in each sequence. And we're not given the rule for the sequence, and we're not given a formula. So we just have to determine what we do or how the sequence is created. So sequence in example A here is 2, 4, 8, 16, 32. So this is 2 times 2 would give us 4, and 4 times 2 would give us 8, and 8 times 2 would give us 16. So in this sequence, we are just multiplying the previous term by 2. So the next 2 terms would be 32 times 2, which is 64. And then if I multiply that times 2, I would get 128. So my answer for the next 2 terms would be 64 and 128. Now B might take a little bit more time for you to figure out. So I have 1, then I have 1, then I have 2, 3, 5, 8. So maybe not, if we don't start right at the beginning, if we kind of start in the middle, we can see that 2 plus 3 equals 5. And if I add 3 plus 5, I get 8. And if I add 1 plus 1, I get 2. And 1 plus 2 equals 3. So we're adding, so this is add the previous 2 numbers. So 5 plus 8 would be 13, and then 8 plus 13 would be 21. In the last example, 1, negative 2, 2, negative 1, 3, 0, 4, you can see that the first and the third and the fifth, those terms are all going up, and the second and the fourth and the sixth are all going up, but they start at a lower number. So 1 to negative 2, I would have to subtract 3, and then negative 2 to 2, I could, let's see, add 4, but then I go back down. So 2 to negative 1 is minus 3, and negative 1 to 3 is plus 4, and minus 3, and plus 4. Okay, so we're minus 3 plus 4. So we left off at plus 4, so now I need to minus 3 here. So my next term would be 1, and then add 4 to that would be 5. Now, the rule, this is just information only, right here. A rule for the sequence in example 2a, so up here, is a sub n equals 2 to the nth power. So find the 10th term of the sequence. We would say a sub 10 equals 2 to the 10th power. And this you would use a calculator for, because let's see, we'd take 2 times 2 times 2, we'd do that 10 times, right? We'd use 2 as a factor 10 times. And I know, let's see, this would be 4, that would be 8, that would be 16, that's 32, that's 64, and I've got 1, 2, 3, 4, 5, 6 of them. Times 2 is 128, times 2 is 256, times 2, so we double that. Let's see, I'm going to write it down so I don't get that wrong. It would be 2, carry the 1, 11, 5, 12, and I need one more 2, so that would be 1024. So it's doable to work it out, but we can always use a calculator. And if you need help entering this into a calculator, let me know. There's a key that looks like a caret. So you do 2 and then the caret and then a 10. Or you might have a Y, X key that looks like this or a key that looks like this. But I will help you with that if you ask. Okay, a couple more examples. Find the first 3 terms of the sequence given by the formula a sub n equals 1 plus 2n. So remember that n is just going to equal 1, and then it will equal 2, and then it will equal 3 to get the first 3 terms. So we substitute a sub 1 equals 1 plus 2 times 1, and our answer would be a sub 1 equals 1 plus 2, so 3. And we do that again with 2 and 3. So we get a sub 2 equals 5, and a sub 3 will equal 7. So our first 3 terms are 3, 5, and 7. Now, what happens down here? How do we determine the term number if we know the value of the term is 37? So if we know the value is 37, we know that that's our a sub n number. And we would solve this equation for n. So you'd use the inverse and subtract 1 from both sides. Get 36 equals 2n, so divide both by 2. That leaves n equals 18. So the 18th term is 37. Last example for you. The numbers in this sequence are sometimes called triangular numbers, and you can see down here it's because we can arrange the objects into triangular patterns. So 1, 3, 6, 10, 15, and so on. And triangular numbers can be found using this formula right here. A sub n equals n times the quantity of n plus 1, all divided by 2. And if we want to find the 10th triangular number, remember that's the term number, so that's n, we would substitute 10 for n and then evaluate. Now remember your order of operations, we have to simplify the parentheses first. So we end up with 10 times 11 all over 2. Now I can simplify this because these are factors, so I can divide the 2 into the 10 and get 5 times 11 is 55. So the 10th term in this sequence is 55. So that's all I have for you today for sequences. Just a different way of looking at it, but make sure that you're using the formulas and you recognize that n is just the term number, the position that the value holds, and we substitute whatever they give us in for n in all of the spots, and we evaluate. Okay, with that, I'll see you in class.